Institutions and businesses collect data so that they can analyze the data and make informed decisions about where they're going to go next with their products and ideas and inner organization. Before we look at how they collect the data, we'll just look at the types of data that they might seek to collect. Okay, so the first type of data, well, data can be broken into two parts: categorical and numerical. Okay, so categorical is data which fits into groups or categories. Okay, and words generally describe these categories, like the color of a car, if something's true or false, male or female. And categorical data itself then can be further broken down into two types of data: nominal data, where data is presented in no particular order really, or ordinal data. Data is presented in order, i.e., we might ask people we're collecting data to agree, disagree, strongly disagree, or strongly agree. So we'll put the data in a certain order, and that's ordinal data from the categorical group. And then the other type of data is the numerical data. Okay, and that's data which can either be counted or measured or referenced on some sort of scale. So there's two types of numerical data. There's discrete data, which is data that has a fixed value, like the number of goals scored in a game, the number of boys who wear blue. It's a fixed number, if you like. Whereas the other type of numerical data is continuous. So that's data that's measured on some scale, i.e. the weights of students in a class or the heights of students in a class. But it's data that can take any value on that scale. So time, measuring time, time to run a race, and so on, is an example of continuous data. Okay, and I have some other examples down here. Let's bring this up a bit. Other examples of continuous data. Discrete data first. The number of pages in a book, shoe size, the number of people in a place. So it's kind of a fixed number, whereas continuous data can be temperature, the length of a movie or a film, or the time to run a race. Okay, so we'll just look at these examples here. It might give us a better idea if we work through a few. So we'll consider some examples of data, and we'll see, are they numerical or categorical? Are they nominal or ordinal? And are they discrete or continuous? So the number of goals scored in a hockey game is numeric or numerical data, and it's discrete. The temperature of an oven is numerical data, and it's continuous, and this is because temperature can take any value from the scale, and also that the temperature is a measured variable. People's hair colour, that's categorical type of data, and it's nominal rather than ordinal. It's nominal in that it's not in any particular order, the hair colour. Okay. Countries where cars are manufactured is categorical as well. The countries would be the word to describe the data, and the data is in words, the names of the countries, and it's nominal data, so it's not in any particular order. Okay. The star ratings of the qualities of hotels, that's categorical, but it's ordinal, so there's 1 star, 2 star, 3 star, 4 star, 5 star. There's different, there's an order there of the data, ranking from good to bad or high to low or whatever. And the time taken for athletes to run 400 metres, that's numerical type of data, and it's continuous because it's measured on the time scale. And some further examples here. So the number of coins in your pocket, that's numerical, that data, and it's discrete because it's a fixed number. The number of tickets sold for a concert is numerical, and that's discrete. That's a certain number of tickets were sold. The weights of people in the class, that's numerical, and it's continuous because we can check those weights on a scale, or we can compare them to a scale. a scale of weights, going from low to high, not a weighing scale. And dress sizes then, that's a numerical type of data, and that's discrete as well, in that a person will have a particular dress size. So in summary then, data can be broken into two types. Categorical is the first type, which can be further broken down into nominal and ordinal, or the other type of data is numerical, which can be broken down into discrete or continuous. Now just an extra bit here, if you're watching this video and you're doing the senior cycle course, just to note that there's other types of data. There's univariate data, and that's when one item of data is collected from each member of a group, like eye colour. And then there's bivariate data, when two items of information are collected from each member of a group. So might have a sample group, and we'll find out from each of those their height and their weight. So that's known as bivariate data. If we were looking at someone's hair colour and their gender, that would be bivariate categorical data. If we were looking at the number of rooms and the number of children in a house and the children that live in the house, that would be an example of bivariate discrete data. So we collect data to make informed decisions, and we just to note first of all that in collecting data, it can be time consuming and it can be expensive. It depends of course on which method you use to collect the data and how you collect it. Okay, so there's two types of data that we can collect. There's primary data and secondary data. Okay, primary data is data that's collected by the user for use to make their own decisions. So it's data that's collected first-hand via different types of surveys. Now surveys can take several forms, but the three main forms are questionnaires, observations, and we'll look at experiments in a minute. Okay, so questionnaires involve respondents answering or filling in questions which are or should be short. They should maybe provide opinion scales, agree, strongly disagree, the scales where necessary. They should provide multiple responses so people can tick yes or no or whatever. This questionnaire should start out simply, just to get the person into the groove of answering the questionnaire, not difficult to begin with. They should give response tick boxes. They should avoid leading questions, do you think the government are doing a bad job? They should avoid personal questions, what weight are you? And they should avoid bias as well, in that you don't want to ask questions or pose questions that's kind of forcing your respondent to only answer in a certain way. And the questions should be to the point and they should not be vague. Okay, so that's questionnaires. Observations then are simply carried out by people collecting data where they're just monitoring other people's behaviour or other objects like cars, traffic systems and so on. The third method of collecting primary data is via experiments, okay, where people carrying out the experiment use data capture sheets or tally charts, which we met in first year, to record data So these data capture sheets are otherwise known as frequency tables. Okay, and here's an example here. 20 people were surveyed about the number of cars owned in their household. This is the data collected. So some had two, some had one, some had two, some had no car in the house, some had three, and so on. So to draw the frequency table there, we can see that the range of data goes from no cars to 4 cars. There's 0 to 4. And we have this tally, T-A-L-L-Y here, and we count the zeros. There's 2, so it gets 2 marks there, and so on. And we tally up for each piece of data here. We include it in our data capture sheet or our tally chart. And then we note We have our tally marks, but we convert them into numericals, so we have two tally marks as 2, 7, 8, 2 and 1, and this is the frequency. So they met with two households with no cars and so on, and the frequency should always total up to the number of respondents, so that's 20. And that's just a basic example of a frequency table or a tally chart or a data capture sheet, whatever you want to call it. The second type of data that we made mention of is secondary data. Primary data is data you collect yourself. Secondary data is data that's already collected. It's published in libraries, it's published online on the internet from another source. So someone else has gone out and gathered the data, and it's there for people to use the data to do an analysis and draw other conclusions. Okay, but the problem with secondary data is that it may be out of date, may be unreliable, and you don't really know how it's been collected. So, if at all possible, if you're doing, if you need to find out some information and to make an informed decision, you're better off trying to use one of the primary data methods to find that information for yourself. But as we mentioned at the outset, that can be expensive and it can be time consuming. And finally, now we're just going to talk about sampling. So let's say that someone made the statement that rugby players in Ireland are taller than footballers in Ireland. Well, it's a broad sweeping statement, and we could go and find every rugby player in Ireland and measure their height, and every footballer in Ireland and measure their height, but that would be very expensive and take a long time to do. So let's look at how else we might go about testing that statement. Okay. Well, the first thing to note is that population is the term used to describe all the rugby and football players in Ireland. So that's all of them in Ireland. Okay. And we would seek to collect data from some of the population, and this some group is called a sample group. Okay. And the size of this group, or the size of the sample, is important. If it's too small, if we only compare two rugby guys with two footballers, it's going to be unreliable, the conclusion we draw. But if it's too large, if we try and speak with 1,000 rugby players and 1,000 footballers, that's going to be expensive to do. So we have to find some suitable sample size. Okay, and we have to be careful of bias. We've met bias before, so we have to make sure that the sample group is properly selected. Okay, because if they're not, then the results may not represent the population. Okay, and that would lead us to different. That would lead us to bias, of which there's different types. So, one example of bias is if you choose the wrong population. So if you were doing a school survey and you only ask leave inserts about a specific issue, then that leaves out the opinion of the first year, second year, third year, fourth year's TYs and everyone else. So that would end up give you a biased, biased data. Okay, and in a similar way, you might pick a sample group that's not representative. So you might go to a casino and only ask gamblers about what they think about gambling to find out a new way to go forward with. Or you might pick people who simply just don't respond to the surveys, some of the sample group, and that would bias the data if you're only analysing 20 returned questionnaires out of 40. And then sometimes you might get all the questionnaires back, but you might have some dishonest answers there. So there's several ways in which the data can be biased, or we might say that the data can be polluted. Okay, so to get around, to work towards carrying out a survey which involves sampling, then often statisticians use this method called simple random sampling. Okay, and it's one way to avoid bias. Okay, so if we have a group of people that we want to create a sample group from, then we might put give each member a number, put the numbers into a hat, and just simply pick a random sample group. Okay, so that's kind of the fairest way to do it, to get some fair data. And often on your computer, or sorry, on your calculator, there's a random number generator as the shift hashtag R&D number. Sorry, if you click shift and the decimal point, so shift and the decimal point, and that generates the RAN hashtag function, which will give you a random number. It might give you something like 0.75, but don't worry about the decimal point, just use 75, and the person in who you've allocated the number 75, if you have 100 people that you're pulling 10 from, that's the person you go with. Okay? So all we've looked at there really is sampling, and what's important about sampling is the size and the bias that can creep in. So one way to avoid that is to just take a simple random sample by just putting people's names in the hats and choosing your sample group from that.